Okay, we're coming to the end of Chapter 2. In this lesson, we'll look at that briefly at that problem of computing a loan payment, and particularly how to implement exponents. Follow up on our data types with our primitive data types, talking about the char or character data type. Remember, there are 8 data types that are primitive to Java. 4 are the integer data types, and 2 are the decimal or double and float inter types. That's 6. Character is 7. And in a lesson or two, we will learn about the Boolean data type. Okay? We may look at a problem, develop maybe an algorithm to compute change in terms of monetary, where we have a given amount such as $5.37, and need to figure out how many dollars, nickels, dimes, quarters, etc. Would make up that amount. Okay. And importantly, we'll look at the string data type. A string is not a primitive data type. It is we call it a reference data type. It's capitalized as compared to the primitive data types that have lowercase. By being a reference data type, there are many methods that we can use to manipulate strings. Importantly, we will look at documentation conventions. We'll also look at different types of errors, and just maybe briefly look at how we can debug programs. We can follow the source code as it's running and look at variables, values, things like that to determine where our errors are. Well, just as a matter of review, we ended the last session talking about a program that would compute loan payments. It's listing 2.8 in your chapter. Needed to explain how to take that amount, 1 plus the monthly interest rate, and raise it to an exponent, number of years times 12, which is basically the number of months that a loan is outstanding. Recall that I mentioned that the math class, much like the system class, is built in to the Java development kit. We don't have to import the math class. It's already there. And that the math class has a method called pow. And the results of pow is that it returns a double, so we'll compute a double value. And the arguments to pow, the things that are inside the parenthesis, are the base, the number you want to raise to a power, and the exponent. So you can see the example of how we would raise 1 plus monthly interest rate to the number of months. The base is 1 plus the monthly interest rate, and the exponent is simply num of months. Recall that we can do root, square roots, cube roots, quarter roots, whatever you desire, simply by using a fractional exponent. Okay, let's explore the character data type for a while here. The character data type is denoted by the CHAR, and that's the type. Note that we can assign the value of a letter to a character data type, and we can also assign the value of a digit, such as the number 4, to a character data type. Now that in num_char there, that would be treated as a character, not as an integer or a byte. So we can't do arithmetic with it. So where would we use something like that? Maybe in denoting a department number or something of similar of that nature. Also, we see that the A and the 4 come from something that says ASCII, which is the character set, the specified character set that represents the letter A. ASCII stands for the American Standard Coding for Information Interchange. And that has been traditionally the way letters have been coded in the PC. So the ASCII character set defines the binary configuration, how the 8 bits are arranged to represent a capital A as compared to a lowercase a, or as compared to the 4. Okay. The second two examples here accomplish the same thing, all right, but they're using the Unicode character set, which the more modern computers, if you've have bought a computer in the last probably 8 to 10 years, it supports the Unicode data set, character set. It uses 16 bits to represent a character. So where the ASCII character set could only represent 255 characters because it was 8 bits, the Unicode character set can represent over 65,000, which now says we can represent the Chinese characters. We can represent characters in some of the languages like Spanish or German or French that have special diacritical marks, things like that. Okay. So what do we see here? Well, first of all, if we look at the assignment for the letter A in a Unicode, all right, we see the /U, which says we're going to be using the Unicode data set. We see 2 zeros and a 41. Well, those are hexadecimal digits. Hexadecimal is a shorthand way of representing binary, and each hexadecimal digit represents 4 bits in binary. So below the 0041, you see what the binary would be. All right, a 0, 4 bits would be all 0. Another 0, 4 bits would be all 0. And then the 4, so the next 4 bits there, would be 010, and then the 1, 001. So it's simply hexadecimal means base 16. It's you know that computers use binary to represent things in memory. Hexadecimal is another computer type character representation that is a little bit more easy to use than the binary. Looking at the Unicode representation there's a couple of things that are very important to point out. The backslash is important. That's called an escape character. And then the U, following the escape character, tells us that what follows is the Unicode representation of a value. Right? Something else to point out. Notice that when assigning a character to a character data type, so when assigning the A or the 4, or even in the Unicode notation there, we have single quotation marks. That's important. The single quotation mark sets that A or that 4 apart from a string type. A string type would use double quotations. So if that character type letter equal A would have double quotes surrounding it, the compiler would throw an error and saying that it expected a character type but found a string. So simply remember that when assigning character values, you need to use the single quotation marks. The next slide will see some additional use for the escape character. Since everything in the computer is represented in binary, with the character data type we can use the increment and decrement operators that we have learned about in the last lesson. So if we did something like plus plus for the CH, that would increment CH, and the letter that would follow a lowercase b, A, would be a B, a lowercase b. So if it becomes important, it's something that you can keep in mind that you can do with the character. So this chart shows several special escape characters that can be useful in formatting messages to the user on the screen, or even when we learn how to send output to a printer. These escape sequences can be important. I would pay attention simply to the escape sequences. I would not expect you to know the Unicode sequence. They're just a hexadecimal representation of what we see in the escape sequence. So just simply the left-hand column. So the escape sequence is part of any string that we use, and simply the backslash and the character. So so many times we want to maybe put our message on 2 different lines, and yes, we can write the first line with a system.out.print line, and then a second line as system.out.print line could accomplish the same thing. But if we use the backslash new line character, we save ourselves a little bit of coding. So I've got a little quiz here for you, and ask you what that system.out.print line would display on the screen. So simply pause the video, and let's take a look a minute and see if you can determine the output. Well, did you recognize that it would put double quotes around my first name, and that it would do a new line, would go to a new line before it ended up printing my last name? So you can see how maybe knowing how to use these escape characters would be useful in your programming. So this chart represents the ASCII character set in terms of decimal numbers. So the very first character in the character set is the character 0, value 0, 0, 0. So null would be the very first character represented in the character set. The way you read this chart is that the first digit or value is in the left-hand column, and the second value is in the top row. So you can see that if I go down to row 6 and I go over to an A and then look up the column, that an A is the 65th character and a B is the 66th character. And so if you think about how a 65 is represented in memory in binary and a 66 is represented in memory in binary, this is why when the computer sorts data, an A would come before a B, and a C would come before a D, because a C would be a 67, 68, so they have these numeric values assigned to them, but only in binary. As you progress in your computer science career, this will become more important to know these values somewhat, right? But the ASCII character set not only, or a character set, not only represents how data is represented in binary in the computer, but also how data is ordered, how letters and characters are ordered and what order there are. Consequently, you can see from this chart that in row 9, right, a lowercase a is a 97. And this is why an uppercase A, 65, is different from a lowercase a, 97. That's basically all we need to say. The notation at the top, that the ASCII character set is a subset of the Unicode character set, and that's true. You'll find that all the ASCII characters are represented in Unicode as the first two hexadecimal digits being 0. Consequently, we don't have any problem of moving between Unicode and ASCII in our character representation. Okay, this problem represents how to determine basically change from a given dollar amount. So for example, if you were given $5.37, how many dollars, nickels, dimes, pennies, quarters would that be? Well, we know it'd be $5 bills, right? And so that then we could look at how many, what's left is 37 cents, and how many quarters are in there? 1. And what's left after that is 12 cents. And how many dimes in there? 1, which leaves 2 cents, which means there's no nickels, and 2 pennies. So $5.37 would be $5, 1 quarter, 1 dime, and 2 pennies. That's the type of problem that we're faced with here, is figuring out a program that would determine the dollars, quarters, nickels, dimes, etc. So we're going to first develop some pseudocode. The solution to the problem is going to involve division. It's going to involve using the remainder operator, and it's going to involve some data typecasting. We do not need to show any of the typecasting in our pseudocode, however. Okay, here are our pseudocode for the algorithm to solve this little problem. After the key point here is after the user has entered a value on the keyboard, we want to convert that to cents. So we'll simply multiply by 100. So whatever dollar amount the user enters, we convert to cents. And then you can see as we go down through steps 4, 5, 6, etc., that we kind of have a repeating pattern. In order to determine how many dollars we know that we have, I use RA as an abbreviation for remaining amount. We have 100 cents in a dollar. So whatever pennies or cents that I have, if I divide by 100, that gives me the number of dollars I have. And then in step 5, if I take the remainder of dividing by 100, that gives me the remaining cents. And so now I have my cents. And then repeat this. The next denomination is quarters. And so I divide by 25, the cents by 25, and that tells me the number of quarters I have. And then I get the result of the remainder of dividing the cents by 25, and so on. So it's a pretty straightforward algorithm. Notice that the choice of the divisor is important in solving the problem. And finally, I display my results. So pretty straightforward algorithm. So we're going to do a little desk checking of our program. Desk checking is going through the code and acting as if we are the computer. So we're going to pick up from the point where the user has entered the dollars and cents, and we'll suppose that the user has entered $11.56 and it's stored an amount. So the first thing we needed to do is to convert that amount to pennies by multiplying by 100. Now, an important piece here is that when we do this, we need to make sure we cast the value of that multiplication as an integer, because we're going to be storing the result in an integer. We can only do remainder operations on integers. If I didn't have the integer cast operation there, amount would be double. Amount times 100 would be a double. So we need to cast it as an integer, and that's important. The next step in our program here takes the remaining amount and divides it by 100, following our algorithm, to determine the number of dollars. And we see that the result is an integer number of dollars, so that will truncate any decimals that is part of our division there. And we're ready to move on to the next step. Well, after we determine that we have $11, we need to determine the remaining cents. We can do that by using the remainder operator, and you see we have a remainder of 56 cents. So after determining the dollars, our next chore is to determine the number of quarters, in which case we have to divide by 25, and we see that our result is that we have 2 quarters. So we're going to be dividing 56, the remaining amount, by 25, and that gives us the integer 2. Well, we found the number of dollars, 11. We found the number of quarters, 2. We need to find the number of cents remaining, and again we can use the remainder operator with the 25 as a divisor, and we have 6 cents remaining. So from here we continue that process that just kind of repeats dividing remainder, dividing remainder. Okay, we've looked at the primitive data types. Remember, primitive data types are built into the language. The 6 numeric types, 4 integer and 2 decimal. We have the character data type, which we just covered, and we have the Boolean data type, which we will cover in a future lesson. Well, there's how do we deal with strings? Well, there is the string data type, and the string data type is not a primitive data type. It's a data type that is built from a class. So it's a predefined class that is automatically included, much the same way as the math class and the system class are included as part of the Java development environment. And we call the string data type a reference data type, simply because it's a class. Any class can be a reference data type. So we will cover more on the string data type, the ins and outs of it, because as a class it has methods and properties that we'll explore. But for now we need to know that the string data type is a reference data type, and the next slides will review this idea of concatenation. Chapter 7 will cover more on using the string data type and using some of its methods. Alright, this gives examples of 3 different concatenation scenarios. One of the things it does illustrate is that we use the double quotes for a string, right, and the single quotes for a character. So if we look at the first one, we have 3 separate strings, and when we concatenate those, they become message becomes 1 string, right, out of those 3. Notice that when we're concatenating, we have to leave a space, between our words. Well, if we want to be able to read it. Otherwise, the words would just be all jammed up against each other. The second example shows that we can concatenate a string with a numeric, right? And also illustrates that I didn't leave a space after the word chapter, so 2 just appears right after the word ends. And the third example there is concatenating a string with a character. And so again, I want to point out, strings use double quote marks, and characters use single quote marks. So let's talk a little bit about programming style. Much of this we've already discussed in class about comments, naming conventions. So just to reinforce some of that, we're concerned about style because it makes your program more readable. It's easier to maintain and change if you adhere to some type of conventional style. So the first thing is comments, and comments are a way of documenting your program, reminding you or somebody who is reading your program what's going on. It's appropriate to have a header as part of your program with your author and date written and those type of comments, the purpose of the program. And then in the body of the program where calculations or certain activities are taking place, it's appropriate to document those too, to maybe remind you what it is you have intended to do with that block of statements and so forth. As we see, there's multiple types of comments. The double slash is a single line comment. It can be on a line by itself, or it can be on a line at the end of a statement to indicate what that particular statement was doing. Multi-line comments, the slash asterisk and the end of that with an asterisk slash, is just exactly what it says. So more of a paragraph comment in a paragraph nature. Now those two types of comments can appear anywhere in your program, anywhere in the source code. There is a final type of comment we call the Java doc comment, and it begins with a slash and a double asterisk, and it must appear as the first statements in your source code before any class definitions. You need to, if you're going to use Java doc, we can put those comments before our class. Kind of the importance of Java doc is when you get to be doing more professional programming. The Java doc comments can be extracted by a program and rendered into HTML, so your comments can look like a web page. And as we will learn when we start investigating the API, your comments will look very similar to the API documentation. For now, we will simply use our single line and our multi-line comments along with the prescribed header that I've given you, which is a Java doc set of comments that has to be inserted right at the beginning of your program. There's many things we need to name in Java. We've been naming our classes. We've been naming our variables. We've been naming constants, and we've been even naming methods. And so by convention, there's certain recommended ways of creating those names so that they're easily recognizable by somebody reading the program as to what they might represent. First, in the most important rule, the most important convention, is that you need to choose meaningful descriptive names. Name things to represent what they are. Use names that represent what something is. All the rest of the conventions do not affect Java. So if we didn't obey by these recommended conventions, our Java programs would still be legal programs. They'd just be very confusing to a reader who has learned these different conventions. So the first one we talked about is the class names, and that we begin class names with an uppercase. Okay? If we have multiple words, notice we use that camel casing. All right? Variables and methods begin with a lowercase. And if we have multiple words to describe or identify the item, we'll use that camel casing, but we always start in lowercase. Now, how can a convention that I have observed and I've seen other programmers observe is that when we are creating an identifier name for a variable, is that we begin the variable name with some type of a prefix, an abbreviation that identifies the data type. So you see my example there of sales tax rate being identified as a double data type. Methods, the only method that we have used so far is the main method. Right? We haven't really explained that as a method, but it is. It adheres to the same rules. It starts with a lowercase, and if we had multiple words, we'd use that camel casing. And since methods aren't a data type, we wouldn't use that prefix. So that's one way of distinguishing between a name that is a method and a name that is something that's a variable. if a variable is using that prefix. And constants are, by convention, all uppercase. And now with the all uppercase, we can't do camel casing, so we can separate the multiply words with an underscore. So if you adhere to these conventions, your programs are going to be much more understandable. And following the arithmetic rules that we've covered in the last couple of sessions, we're not going to run into problems where we're trying to assign a narrower type to a wider type and those type of errors. At least we might run into them, but they might be more noticeable in terms of debugging. Well, just as formatting makes your research reports more readable, some formatting also makes your programs more readable. One is indentation, and we will start learning about using different blocks of code. Remember, blocks of code are set off by the braces, the opening and closing braces. So we've seen the class block of code. We've seen the block of code that sets off the main method code. Both of those set off by braces. But we'll learn that we use braces for other programming constructs that we will learn in the chapters to come. So setting those types of things off in spaces, with a couple of spaces or in tabbing, makes things a little bit more readable. Separating some of your code with blank lines. Blank lines don't cost you anything, right? Again, makes things readable. Use some spacing. Introduce the code with a comment, right? And a blank line before the comment. Maybe a blank line after the block of code that you're trying to explain. Okay, up to this point, we've only had to concern ourselves with the block styles for the class and for the main method, and keeping the blocks together with the braces. There's two different thoughts about how you might do that. One is begin the opening brace and on a separate line, the closing brace on separate lines, such as example 1, or at least use the opening brace on the class or the method definition and so forth. Okay. Now, I mentioned in one of my discussions in class that it would be a good idea to comment your braces, so that when you have an opening class brace, you put a comment that this is the beginning of the class. And when you have a closing class brace, you identify that as the closing of a class. One of the difficulties in debugging, all right, is when we have a missing brace someplace and we can't really easily see where that occurs. And so if we comment which one goes with which, if as in this example here, we see that we use some indentation, so it's obvious where the terminating brace, when it's terminating, and so forth. So good programming style, good comments, right? Good naming conventions are all going to make your programming life much more easy. Okay, let's look formally at the different types of errors that you can occur in your programs. I've mentioned these in class before. Syntax errors are errors that the compiler will detect, and so they're error messages that will prevent your program from compiling and becoming executable. There's several common types of syntax errors beyond simply misspelling a name of a variable, or not including the right arguments to a method, missing a semicolon at the end of a statement. Very common. As I mentioned, misspelling a name, right? Or using the wrong case, which is a form of misspelling, because Java is case sensitive. Having unbalanced braces or parentheses will also cause a syntax error. One of the reasons I recommend commenting the beginning and end of your blocks of code, your braces, is to maybe avoid that particular error. Runtime errors are something that will cause your program to crash. It will compile. It means that all of the statements are legal statements, but it doesn't mean that you might have done something wrong. All right. When we deal with files, if you're trying to read data from a file and the file doesn't exist, that could cause your program to crash. Right? Logic errors just simply produce the wrong result. Desk check is all I can say. Know what your results should be. The little problem we had for Monday, where we had to show the Greenwich Mean Time in Central Standard Time, some of you had the wrong results, and you should have maybe recognized that that when you converted to Central Standard Time, hey, this isn't the time it is right now. So desk check. Understand what your output results should be. Well, here's a syntax error. I have highlighted in red where the syntax error occurs. Can you determine why that caused an error? Pause the video and study it a minute. See if you can come up with an explanation. Well, the issue here is that I has not been declared. Right? Remember, when we talk about declaring a variable, it's when we define the variable with a data type, right, at the beginning of the class or method. So we simply needed an int space I semicolon to declare the I as a variable. Well, as a runtime error, this error should be obvious to you. The division by zero is illegal in any mathematic operation that I know of, and so that would cause your program to crash. Now, what might be a little bit more subtle, if that was 1 divided by, say, a variable name, x, and at the time that statement would execute in your program, x might have a value of 0, and that would cause a crash. Nothing you did wrong, right, other than allowing x to go to a value of 0. So simply an example of one of the type of runtime errors you can get. Okay, here's an example of a logic error. Some of the coding is probably unfamiliar to you. The purpose of the program is determine if a number that the user enters is between 1 and 100 inclusive. The J option stuff there is a GUI way of asking the user to do input instead of simply the command window that we have used. I've been skipping the GUI stuff. But more importantly, the part of the line that is highlighted in red is right now beyond our understanding of testing, but I'll tell you that it tests to see if 1 is less than the number that was entered. The 2 and% signs means and the number is less than 100. So the red says, take a look at number. Is 1 less than the number? And is the number less than 100? If it is, then that's going to say true. What is the logic error here? Well, if we look up there, it says inclusive. So if my number is 1, the first part of that statement is going to be false, and so it won't say. It'll give me a false if I enter 1, as well as if I enter the number 100. When we get into the selection construct problems like this, it's really best practice to test the extreme ends. Right? Test this program with entering a 1 and entering a 100. Okay? So that's a logic error. And again, if I did some desk checking, I could catch that error before I tried to run my program and gave maybe the user wrong results. Well, logic errors are sometimes very difficult to determine what particularly caused that error. And the same with sometimes a runtime error. So these are called bugs, and the process of resolving the problem is called debugging. I will try to remember in class, or somebody asked me what the source of the term program bug is, and we'll have maybe a little chat about that. But there's many ways you can debug your program. First thing I recommend is that you, in smaller programs, that you simply desk check your program, act as if you're the computer, pretend that there is some input, see that, go through your program step by step, much kind of tracing it similar to what we did in the lecture for Monday on making monetary change. Sometimes that works, right? You can insert maybe print line statements to show the value of various variables in your program. Messages to you that says, where are you in terms of what statements are you trying to execute. That kind of can maybe show you some values and give you some ideas. The difficulty there is to remember to take those little print line statements out of your program before you turn it over for production purposes. So the best practice, or the maybe the more rich practice, is using an IDE, an integrated development environment, much like NetBeans, or sometimes you might see the videos from the author talking about Eclipse, which is another integrated development environment. But most integrated development environments, regardless of the language, have several debugging capabilities built in. They allow you to watch your program execute one statement at a time, and it stops, right? And so you can study the statement. You can display the value of variables. Some will let you modify the value of the variable. So maybe you investigated, examined the variable, and you say, that's not the right number. I don't really want to divide by 0. But let's see, if I don't divide by 0, will the answer to this particular problem result in something that is correct. So kind of a nice way of checking your program. Problem is, on that you have to go back and figure out, well, why did my variable become 0? Could be legal, and then you have to do some things for testing for that and taking care of it. You can set breakpoints. A breakpoint is simply a stop sign, and it tells the integrated development environment, all right, I know everything up to this point is correct, so run the program to this particular line, and then it will stop. Right? And then you can start executing step by step, investigating the value of variables and so forth. A good practice in large programs, right, is this incremental development and incremental testing. Write a small amount of code first, compile it and test it, right? Know what the result should be. Then write a little bit more code, compile it and test it, right? If you do that, for each time you compile and test and clean up that code, you're getting a smaller and smaller error service. If you write a 1,000-line program and never test it until you're all done writing the 1,000 lines, you're going to be scratching your head for quite a while. So my recommendation is incremental development, incremental testing. All right, be sure to print off the supplement that talks about how to debug with NetBeans. Also, check out the video that is on Blackboard about debugging with NetBeans. Don't worry about a full explanation of all the code that's being debugged, but just the process of debugging, process of using the NetBeans debugger is important. Okay, well that does it for Chapter 2. We have explored variables, have explored how to do various types of arithmetic, looked at data casting, remember changing it temporarily from one type to another, talked about the string type, and we've discussed some programming conventions, things to make your program a little easier to read, a little easier to debug, and kind of finally wrap this up with using the NetBeans debugger. On to next week, when we'll start using the selection construct, so we can start building programs that are a little bit more interesting.